thought I'd talk about prototyping. How many people here have actually built a prototype of something? Nice. All right, cool. So it'll get a little technical. Stop me if it's too much, and I'll move on. So first of all, I'm one dude. I have pretty strong opinions, but I hold them pretty weakly. So feel free to disagree with what I say. I used to run a design consultancy for product design. Many of you know companies like IDEO. These guys help companies do all kinds of the product development process, typically on what's called a fee-for-service basis. IDEO, probably everybody here knows IDEO, Frog Design, another big company. Smart is big here in New York. These guys are helping companies do design, prototyping, and usually early manufacturing for a wide variety of products, usually in the consumer space, sometimes medical. These are some random products that I've worked on at my last firm. These are just three totally random things that I picked out. This is a car company called Ferrari that you may know. This is a crazy, ridiculous $20,000 stereo speaker system. Crazy $20,000 stereo speaker system. The theory here is that you drive your $1 million Ferrari Enzo like 3 days out of the year, and you want to show that you own one of these things. So you tick a little checkbox at the bottom of the order form, and you get one of these $20,000 speakers in your office, so you can say, "Hey man, I own this cool speaker." Super fun design project. A little silly, if you ask me. This is a piece of furniture that we were asked to design for a couple of museums. Modular furniture, so you can see there's like straight sections and curved sections. You can pick it apart really easily and like rearrange the way you sit. This is a first MFI approved accessory for the iPhone that hit the store shelves. So this is actually a universal remote control for your phone. So you can pull up your phone and you can control your TV, DVD player, VCR. So a huge range of things: consumer electronics, green energy, furniture, car products, etc. I learned through this process. I ran this company for about 5 years and learned that startup companies are way more fun than these giant companies with thousands of people. So I started a company called Volt, which you may have guessed, which helps really young hardware companies get to market. Early stage seed fund, but when we make an investment, it comes with prototyping equipment, a full staff of engineers and designers, an awesome shop that companies can use, help with manufacturing, etc. I'm not going to talk too much about that, but you're welcome to come up and say hi if you want to learn more. So talk a little bit about prototyping here. I think prototyping is one of the most important components of building a company. If you do it incorrectly, chances of failure are very high in terms of the company itself. The first thing is approach building prototypes just like you would a science experiment. Make a thesis, say, hey, I want to learn something specific, and try to prove if that thesis is right or wrong. One of the big mistakes that companies make is they try to build these expensive, complicated prototypes from day one. And that takes a really long time, and sometimes you don't know, maybe the color is actually affecting how someone is using something, and you're trying to isolate variables, just like a science experiment. So, does anybody know what this product might be? Yeah, right. So this is Dyson, a great company in the UK. They built this thing that you would never guess is a hand dryer, but this is a hand dryer that you now probably see in airports and stuff all the time. But they were trying to prove if this thing, which is mounted in a totally different way, is going to be understandable by consumers that walk into a bathroom and have to figure out how to dry their hands. So this is something you go to Home Depot, you buy, there's like 6 sheets of like insulation, and you buy like big pink stuff, cut it up into a shape, paint it, and put it on a wall. And you can tell if people are going to actually be able to interact with something like this without spending $10,000 building a functional prototype. Speed is incredibly important in prototyping. You should be optimizing for speed all the time. There's this great book called The Lean Startup, which talks a lot about how to build a hardware or a software startup company. It's ironic because that term lean comes from manufacturing, which was created by Toyota. And speed can be really important in hardware too. It's a little harder. You have to kind of figure out your way a little bit more, but it's just as important, if not more important, than software companies. So how do you move fast? A lot of people are like, oh, this is great. I have a great idea for a product. Let's hire a design consultancy to build it. This is a horrible, horrible idea. It will cost you thousands, hundreds of thousands of dollars, and it will take far longer than you can do it on your own. I'm not going to go into why, but it's true. Trust me, I used to run one of these companies. There are 4 main steps. A lot of people have all kinds of different names for these things. I classify them into 4 categories. The first is what I call proof of concept. This is like totally basic, binary, is this going to work, is this not going to work? These are really, really easy things to build, usually off-the-shelf components. We'll talk a little bit more about that in a second. Next is what we call looks like and works like prototypes. These are two separate prototypes, one of which is focused on aesthetics, user interaction interface, and the other is focused on function, so mechanical engineering, electrical engineering, basic sort of functional paradigms of how something is actually going to work. Design for manufacturability, design for assembly, design for cost, design for all kinds of different things. In the design industry, we call this design for X. This is an incredibly critical component in the manufacturing process, and just understanding what kind of components you're using, how much it's going to cost, where it's going to be made, etc. And then a functional prototype is typically what we call sort of a final prototype. This can take many different flavors for a full product. Often it is something that is totally useful. You can show to a consumer on the street and they'll understand how to use it, hopefully. So I'm just going to talk about some techniques and tips for how to do all these things, which may not be useful to you guys. So the first is as a proof of concept. Anybody know what this is? Super soaker, yeah. So you'll notice these is like all components that you can buy from Home Depot or find in a trash bin. This is actually the first prototype of a super soaker that was eventually sold for lots and lots of money, and many of us kids used to use these all the time. But you see, PVC and hoses and a 2-liter bottle. This was the basic sort of test that this product will actually work. Anybody know McMaster Car? Nice. Yes. I love when that happens. This is the most useful website for purchasing parts for proof of concept prototypes and even production prototypes. But this is about 450,000 last time I checked, 510,000 products. Amazing user interface for finding all kinds of crazy weird screws and stuff. Super useful for prototyping at the very, very earliest stages. Legos are really fun. They're not just a toy. They're actually really useful for figuring out how things are going to work. Cardboard is one of the most amazing materials that people don't really pay attention to enough. You can do incredible, amazing things with cardboard if you know how to cut it and form it and glue it. Here's some examples of works and looks like prototypes. Clay is a great material. This is used in the auto industry for every single model that's made. You can sculpt clay unlike anything else that I know. Wrench shape, this is a material that a lot of people don't know. It's a polyurethane foam that is incredibly expensive, but machines like butter, you can finish it with Bondo and sand it and paint it and all kinds of other things. Really, really useful for really high quality aesthetic prototypes. Bondo, unfortunately, I sort of hate to love this, but it's one of those things that you kind of have to use all the time if you're going to make something look really good. Sanding, same kind of thing. Your knuckles get bare from sanding all kinds of products, but this is a great thing to build really high quality finishes on early products. This is an early prototype of another thing that we did. I don't know if people here go snowshoeing at all. This is a collapsible snowshoe that you can fit into a yoga mat bag that a crazy client of ours asked us to build. This is all formed sheet metal that's cut on a laser cutter and then formed into a shape on one-dimensional press. Amazingly fast to build these. You can make a prototype of this in about 3 hours. Really useful. Obviously, we wouldn't produce this at scale, but it's awesome to be able to test function of things. Great company in New Hampshire that will do rapid prototypes of sheet metal parts in about a day called Rapid Sheet Metal, not so surprisingly. Awesome guys. This is, you can see, it's hard to tell here, but this is a giant CNC machine cutting out parts for the big Ferrari speaker system. This is one half of the speaker. This is about a 22.5-hour machining cycle to do this one part, so it takes a very long time to make these. The machining is a fantastic way to test function of things, even if it's not feasible to build them in production. Again, lathe work. This is a part for the chair, that the little red segmented chair thing. A piece of bamboo that actually is a great material to prototype in, believe it or not. Urethane casting, molding. It has a bunch of different names, but it's basically plastic molds, which are really quick to make, relatively cheap and pretty flexible, which is wonderful. Vacuum forming. You take a big mold. Often you can use 3D printed parts, and then you can heat usually ABS plastic or polyethylene plastic on top of it and drop down with vacuum. Really useful for prototyping. And then design for various things. I think I talked about design for manufacturing. So this is the Unity product, the remote control thing I talked about for Apple. So these are SLA parts that are finished to an incredibly high tolerance with a wet sand, which is how you get those really nice glossy parts. And this is actually how all the website and promotional material is done, with really basic sort of 3D printed parts that are finished really nicely. These are all pre-production. These are not coming off of a mold. What is this? Oh yeah, so this is another SLA print, which is checking for assembly parameters. You can see things like screw bosses here that we're trying to figure out how you're going to be able to fit a screwdriver into something to understand if assembly is going to be easy and efficient to do. Something that all startups building plastic enclosures should go through. It's amazing how much time you can save by spending just a couple of minutes in the design process thinking through these kinds of things. This is a great company in our hometown of Boston, Formlabs, which builds these awesome desktop-grade SLA printers. Again, printing is a really fantastic way to do prototyping. I'm not sure if it's great for a lot of other things, but it's really good for prototyping. Awesome company called Protomold in Minnesota that you guys may know. Does what they call rapid injection molding. These guys can turn injection molding parts around in about 36 hours, which you pay for, but it's amazingly useful. And they're super helpful. You can upload like a solid model of your product, and they'll actually tell you, oh, your draft angle is too steep or too shallow. We can't actually mold this. Really useful. And they'll tell you how much each part's going to cost, how long it's going to take. This is the simplest injection mold tool I've ever made. This is the B cavity here. I don't know if you guys are familiar with injection molding. This is how like almost all plastic things are made. They take really hot plastic and shoot it into pieces of metal and try to form them as they cool. So this is actually a two-dimensional part, which is very easy to build. Great, actually sometimes really useful for a prototype. If you're building a couple hundred or something, you can get molds made in China for pretty cheap, surprisingly cheap. Okay, so this is a bummer part. After you're done prototyping, you have to actually make a lot of these things. And this is, unfortunately, there's no like easy answer to do this. So here's a couple of like random tips that are related to that. This is what I call the uncanny valley of manufacturing. And it's really easy to build like 1 in 5 of something, and it's actually pretty easy to build like hundreds of thousands of something. When you're building like 1,000 of something, it sucks. And unfortunately, this is like where everybody wants to start. It's really, really unfortunate, but that's just kind of the way manufacturing works. A lot of times people seem to go to China to do what's called a box build, which is like full assembly of the product. So they do the plastics, they do a PCB, they quality control everything. Most factories will have what's called a minimum order quantity, and this is usually in the 5,000 unit range. Sometimes if you're just doing one thing like a circuit board or just a piece of plastic and they're going to ship plastic back to you, you can get away with other things. But most factories have a 5,000 unit minimum order quantity. This is actually a picture we took from, we took some of the bulk companies that we invest into China to show them what manufacturing is like. And so this is a view down, and amazingly, it's hard to tell how big this room is. These are all guys manually reworking. These are injection mold tools that I showed you in one of the other slides. These are guys by hand fixing tools. Totally amazing. There's probably 100 people in this room at Bridgeport's. Jigs and fixtures are amazingly, amazingly useful. And this is something, even if you're doing a large-scale production run, thinking through how you're going to fixture something is incredibly helpful. Not only for you, but for the manufacturer as well. Your quality rates will be higher if you actually think through how something's going to be held or screwed together or glued together. So this is like a super basic jig we were making for that chair thing. We made 10 of these in-house. These are V-blocks from, if you guys are machinists, these are V-blocks which you can get anywhere in any machine shop, and some wood and screws. This saves hours per chair to build. Really try to avoid doing this. This is one of these things that unfortunately we're really bad at estimating numbers in our head. I don't know if it's like base 10 math or whatever, but you think, oh, no worries, I can build 1,000. That sounds easy. And then like the boxes show up at your door of huge freight things, and you're like, I had no idea how many things we were going to have to assemble here. So this is what happens when you make that mistake. This is that snowshoe product. This is the next revision of the prototype. These are the injection molded parts. I think we did 500 pairs, which is 1,000 units, and that's not fun. You sit down and do the napkins math, and you're like, oh, this is going to take, it takes 5 minutes to assemble one, so it'll probably take, 2 days to build them all. And 3 weeks later, you're like still hammering things together. I'm not an electrical engineer, but there are some great things you can do for PCBs that are super helpful. This is an awesome tip that a lot of companies use where they they don't eat these, but they put them into skillets. Instead of having a $1,000, multi-$1,000 reflow oven, which is what most assembly houses do, they just put a skillet or a toaster or a hot plate or something and they just throw them on there. And this actually works pretty well. Again, don't do this for like 1,000 or something, but for 50 or 100, it's great. Everyone thinks this is a great idea. Like, I'm going to make my own PCB boards. This is going to be great. This is a horrible idea. For amazingly cheap, you can have another company do this for you. And it is just not worth the time, energy, complexity, cost, etc. to do this on your own. So just don't do it. Typically, in most products, these three components will drive cost. So battery, MCU, your microcontroller, and any communication chip that you have, radio, cell module, Bluetooth, whatever. Focus a lot on optimizing these three parts, and don't worry about the part number of your capacitor, because that's a commodity part that you don't have to think about. Often there's one or two other parts that will drive cost too, depending on what you're doing, but these three tend to be common with a lot of the products that we've worked on. Yeah, this is a huge mistake that a lot of companies make. They are super comfortable. Oh man, I'm going to build this great product around this like $19 Arduino chip, and it's going to be awesome. And then, can you just make 1 million of them, please? And they don't realize that it's actually not. You basically have to start completely from scratch if you're doing something like that. So we've seen a bunch of companies that are working on some weird ass Motorola thing that was made in the 90s, and they're like, this is the best processor we've ever used. And then they go to buy them, and there's like 6 of them left in the world. And that's not good. So spend an hour talking to someone who knows this stuff really well. They'll tell you which processors are cheap for what you need, where to get them, how much they'll cost at scale, etc. It saves you a huge amount of time. I'm totally biased because this is one of my partners at Bolt. Dragon Innovation, awesome company, helps companies do their first manufacturing runs in China. Super, super useful, and they've worked on everything from Pebble to Roomba to Siftio and robotics, and I think the Tesla guys and a whole bunch of other companies that you may know. We're pretty open. I didn't really tell you too much about Bolt, but we're really happy to help companies. Send us an email, Twitter things, Facebook things, and we'll respond as technically as I know how. So I don't know if there's question time. Yeah? Cool.
Yeah, let's just take one.
One's good.
Let's keep